Good evening, class. Starting from where we stopped the other time on application of derivatives. So we looked at various examples on how we can apply derivatives. Today we are going to look at maximization and minimization of functions, or you can say relative maximum and relative minimum. So we're going to look at an example of a relative maximum and relative minimum. The other time we looked at how do we differentiate total costs to get marginal costs. How do we differentiate total revenues to get marginal revenues? So today we are going to look at the use of these particular functions, most especially in firms. For example, we have an example on given the total revenues as 4,000 Q minus 33Q squared, and then total costs is equal to 2Q cubed minus 3Q squared plus 400Q plus 5,000. So find the output at which profits are maximized. So we are going to look at this example and we see how we can compute the profit function. How do we get that output at which firms or this particular firm maximizes the profit. So let's begin with the first question. Now question 1 was requiring us to find the marginal revenue function, and if we have the price, how do we get the total revenue? Total revenue is price times quantity. Now we already have the price, so we multiply the price times the quantity, and that gives us 30Q minus 2Q squared. Now these are our total revenues. So for us to get the marginal revenue function, we have to differentiate total revenue with respect to output. So this is what I did, and then I got 30 minus 4Q. Of course, to differentiate total revenues, I had to apply the rules of differentiation that we looked at in our previous classes. Question 2. Now looking at question 2, it requires us to find an output at which this firm maximizes profits. At what output level does a firm maximize profits given its total revenue function and total cost function below? So what do we do? First of all, we need to find how do we find the profits of a firm. The profits are given by total revenues minus the total costs. Or we can equate marginal revenue to marginal cost if you want to get a profit function. Either way that works. So here we decided to subtract total revenues minus the total cost, and that gave us what we have as a profit function. So the profit function we got was negative 2Q cubed minus 30Q squared plus 3,600Q minus 5,000. So this is the profit function that we differentiated. So we differentiate profits with respect to output, and then after differentiating that profit function, we came up with negative 6Q squared minus 60Q plus 3,600. Remember, when we were discussing relative maximum and minimum, we said this is a point at which dy dx is equal to 0. The function is neither decreasing nor increasing. At that point, the function is 0. The function is equal to 0. So dy dx is equal to 0 for that particular function. Or you can say the rate of change of that function at that particular stage, it is equal to 0. That's what we said when we were having our discussion on relative maximum and relative minimum. So at this time we state that at maximum stroke minimum, dy dx is equal to 0, and then that means that we are going to equate our derivative to 0. So when we differentiate profits with respect to output, and we say is equal to 0, it means that we equate that derivative we got to 0. So our derivative was negative 6q squared minus 60q plus 3600 is equal to 0. So this is a quadratic equation. At this point, since we have a quadratic equation, we can either use factorization or bulldozer to solve for q. Now, I used bulldozer, and that is the formula that we call bulldozer, but one can also factorize, and then you get the values for q. So the values for q, we got two values, q1 as negative 30 and then q2 as 20. So these are also known as critical values. These are the values that we are going to substitute later after taking our second derivative, so as to identify the relative maximum and or minimum. Taking the second derivative, remember we said there are two conditions of profit maximization. The first condition is the necessary and foremost condition is dy dx, or in this case you're looking at d pi dq must be equal to 0. And then the second derivative is this one, that we are going to differentiate our first derivative. Or you can say that we differentiate the answer we got on our first derivative, and that gives us our second derivative. So in this case we have d squared pi divided by dq squared. So when we differentiate our first derivative, we get negative 12q minus 60. So for us to identify the output where a firm maximizes profits, we have to substitute these values for q in that particular derivative, second derivative. So for q is equal to negative 30, when we substitute it in this formula, you find that we have positive 300, which gives us a positive figure. And then when we substitute q is equal to positive 20, we get a negative 300. But remember, in conclusion, profits are maximized at a point at q is equal to 20, since this is the critical value that has given us a negative sign after taking the second derivative. So this takes us back in our discussion that when do we say that it's relative maximum or relative minimum? It's relative maximum if we achieve a negative sign or a negative value after a second derivative, and then it's relative minimum when we take when we get a positive value after taking our second derivative. So in this case, profits were maximized at q is equal to 20, and this is our conclusion for this particular example that we had.